Hello and welcome to this lesson. We're going to talk about enthalpy of solution, which is also called heat of solution, that is denoted by delta H. So this is defined as the enthalpy change that occurs when a substance is dissolved in water to form an aqueous solution. For example, 2 grams of potassium nitrate and 2 grams of sodium hydroxide were each dissolved in 100 centimeters cubic of water, and the temperature change recorded as shown below. So the first question, you're told to calculate the enthalpy change for dissolving potassium nitrate. Now we know the formula for enthalpy change is given as mass multiplied by the specific heat capacity multiplied by change in temperature. Now for this case, for us to get the change in temperature that we're going to use, we take the final temperature minus initial temperature. And normally we use temperature in kelvins. So therefore we are going to convert these temperatures into kelvins, then get the temperature change in each case. So 28 degrees Celsius is equivalent to 301 kelvins. 22 degrees Celsius is equivalent to 295 kelvins. 29 degrees Celsius is equivalent to 302 kelvins. 52 equals to 325 kelvins. Now when we get the temperature change in kelvins, we take the final minus initial. So 295 minus 301, we get negative 6 kelvins. So here we note that the temperature has dropped. And 325 subtract 302, we get positive 23 Kelvin. So here we note that for sodium hydroxide, temperature has increased. Now our temperature change that we're going to use here will be equal to negative 6 kelvins. Next, we find the mass that you're going to use here. Now mass, we normally take the mass of solution. For example, when you come back to this question, we note that you've been given 100 centimeters cubic of water. And we know that 1 gram of water is equivalent to 1 centimeter cubic. Therefore, 100 centimeters cubic of water will have a mass of 1 gram multiplied by 100, then divide by 1. So we get 100 grams of water. But normally we use mass in kilograms. Therefore, this 100 grams of water is equivalent to 0.1 kilograms as mass. So next thing, we come and insert everything in the formula. So we are going to have our enthalpy change will be given by mass, which is 0.1 kilograms, multiplied by the specific heat capacity, that is 4,200 joules per kilogram per Kelvin, then multiplied by change in temperature, that is 6 kelvins. Therefore, we get our enthalpy change as 2,520 joules. Now we can convert this one into kilojoules by dividing by 1,000. So we know that 1 kilojoule equals to 1,000 joules. So what about 2,520 joules? So this is going to be equivalent to 1 multiplied by 2,520 divided by 1,000 joules. So we get 2.52 kilojoules. So our enthalpy change in kilojoules is going to be 2.52. Now we go ahead to the next question, which says, calculate the number of moles of potassium nitrate that dissolved in the above experiment. Now we know that moles are given by mass divided by the relative formula mass. So that now the relative formula mass of potassium nitrate equals to 39 plus 14 plus 16 multiplied by 3. which we get 101. And the mass used in the question, you've been told in the question that 2 grams of potassium nitrate were dissolved. So we're going to use our mass as 2 grams. Therefore, we're going to have number of moles equals to mass, which is 2 grams, divided by 101. And thus, we get 0.0198 moles. Part C, you are told calculate the molar heat of solution of potassium nitrate. Now, when you talk about molar heat of solution, this is the enthalpy change that occurs when 1 mole of a substance is dissolved. So here, when we dissolve 2 grams, is the same as 0.0198 moles. And these moles evolved 2.52 kilojoules of heat. So what about molar heat? So molar heat is the same as asking yourself, what about 1 mole? Will you evolve how much heat? Then you cross multiply. So going to have 1 mole multiplied by 2.52 kilojoules divided by 0.0198 moles. So this is going to give you, our molar heat is going to be 127.27. But now when we write the molar heat of solution, we will accompany it with the type of reaction that occurs. So for this case, we note that there was a decrease in temperature. And if there is a decrease in temperature, it means that this type of reaction is an endothermic reaction, where a system has absorbed heat. And if it's an endothermic reaction, the enthalpy change is always positive. So the enthalpy change for this reaction is going to be positive 127.27 kilojoules per mole. That will be the molar heat of solution. The next question, you are told to write the thermochemical equation for dissolving potassium nitrate. Now, a thermochemical equation is an equation that is written together with the enthalpy change. For example, in this case, we have potassium nitrate solid that is dissolving to form potassium nitrate aqueous solution. And the enthalpy change for this case is positive 127.27 kilojoules per mole. So our thermochemical equation will be written as such. It's an equation that is written together with the enthalpy change for the reaction. Then you are told to draw an energy level diagram for dissolving potassium nitrate. First thing we need to know when you are drawing an energy level diagram, we need to know the type of reaction. Is it endothermic or exothermic? Now for this reaction, we have already determined that it is an endothermic reaction. Now in an endothermic reaction, when you are drawing the enthalpy diagram, on the x-axis we normally write the reaction path. On the y-axis is normally energy in kilojoules per mole. So if the reaction is endothermic, then it means that the products have higher energy than the reactants. So that's why you're going to start from the lower side, going upwards, because the products have a higher energy than the reactants. And the enthalpy change here is positive 127.27 kilojoules per mole. So the reactants, we have potassium nitrate solid being dissolved to give us potassium nitrate aqueous solution. So that's how our energy level diagram is going to look like. The next question, you are told to calculate the enthalpy change for dissolving sodium hydroxide. Again, because in that question you are dissolving two things. One was sodium hydroxide, the other one was potassium nitrate. You're also going to say that the enthalpy change will be given by mass multiplied by the specific heat capacity multiplied by change in temperature. So the mass, we are still going to use the mass of solution. That is the mass of 100 centimeters cubic of water, which was 0.1 kilograms, multiplied by the specific heat capacity, which is 4,200 joules per kg per Kelvin, then multiplied by our change in temperature for dissolving sodium hydroxide. Temperature increased by 23 kelvins. So when we do the multiplication, we get 9,660 joules. And we can convert these joules into kilojoules, and this will be equivalent to 9.66 kilojoules. That's our answer here. Now next, you are told to calculate the number of moles of sodium hydroxide that dissolved. Again, we say that moles equals to mass divided by the relative formula mass. And the relative formula mass for sodium hydroxide is going to be 23 plus 1 plus 16, which is equivalent to 40. So the number of moles here are going to be 2 grams, that's our mass, divided by 40. We get 0.05 moles of sodium hydroxide. Then to calculate the molar enthalpy of dissolving sodium hydroxide. So here we realize that 0.05 moles of sodium hydroxide will evolve heat that is equivalent to 9.66 kilojoules. So what about 1 mole? Because molar means 1 mole will evolve how much heat? So going to have 1 multiplied by 9.66 kilojoules, then divide by 0.05 moles. So that will give us 193.2. Now, the molar enthalpy change, we write it together with the sign accompanying the reaction. So for this case, we know that there was an increase in temperature. Therefore, this means that the system was losing heat to the environment. And if the system loses heat to the environment, it is an exothermic reaction. Remember that an exothermic reaction leads to an increase in temperature, but the enthalpy change is negative. Therefore, the molar enthalpy change is going to be negative 193.2 kilojoules per mole. That's fine. And the thermochemical equation for this reaction is going to be sodium hydroxide solid dissolving in water to give us aqueous sodium hydroxide. And the enthalpy change equals to negative 193.2 kilojoules per mole. The energy level diagram for this reaction, we note that it is an exothermic reaction. Therefore, in an exothermic reaction, the products normally have a lower energy than the reactants. So on the x-axis, you're going to have the reaction path. On the y-axis, you're going to have energy in kilojoules per mole. Therefore, for this case, we are going to have an energy level diagram